Hello everyone, today I am going to discuss the fifth problem of AtCoder beginner contest 359, which is water tank. So what is the problem statement? So we are given a long water tank with boards of different heights placed at equal intervals, and Takashi wants to know the time at which water reaches each section separated by the boards when water is poured from one end of the tank. So let's take the first example. Here the images are given. So here he is adding water from the left end, and here are the five ports. First one with height 3, the second one with height 1, third one with height 4, fourth one with 1, and fifth one with 5. Let me draw this here. Okay. Uh, let's say let's say this is the section. The first one is height 1 3 3, the second one with height 1, the third one with height 4, the fourth one with height 1, and fifth one with height 5. Okay, fifth one with height 5. Now he is adding the first unit of water. We can also assume that there is a board with infinite height here. Okay, now let's say he is adding 3 units of water here. First unit of water here, second unit of water here, third unit of water here. Now when he is adding the fourth unit of water, it is getting dropped in the second section, the first section. If you take 0 waste in next thing, so the fourth unit of water is dropped here. So the answer of this section will be 4. Now after adding the fifth unit of water here, this will again overflow. So the fifth unit of water will be added here. So the answer for this section will be 5. Now sixth unit of water will be added. Seventh unit of water will be added. So this will be like this. After adding seventh unit of water, this will be like this. After adding ninth unit of water, this will be like this. And after adding uh, 7 9, after adding more 3 units of water, this will be like this, 12. Now after when we are adding the 13th unit of water, this will overflow and the 13th unit of water will drop here. So the answer here will be 13. Now when we are adding the 14th unit of water, it will again overflow, so the answer here will be 14. Now again we are adding 2 unit of water here, 16, 18, 20, and after that we have to add 5 units of water again, 25, and the 26th unit of water will drop here. So you can assume there is an infinite height cardboard here as well. So the answer for this section will be 26. Okay, so answer is 4, 5, 13, 14, 26. So let's check the answer. The answer is nothing but 4, 5, 13, 14, and 26. So how we are solving this? Okay, how we are solving this? So this problem is kind of greedy problem, right? Right. So how? Let's say when we are adding first unit of water, second unit of water, third unit of water. When we are adding the fourth unit of water, let's say we are moving from this direction. Okay, we are moving in this direction. Let's say we are at this position. Okay, now we up at each index, what is the water we are storing? We can store till this cardboard. What is the total unit of water we can store till this cardboard? So till till this cardboard, till this board, we are storing 3 unit of water. So the answer here, let's take another array. The answer here will be 3. The answer here will be 3. Now after this cardboard came, right? Let me draw this again here. Let's say this is infinite here, 3. The answer here is 3. Now we are adding one cardboard of size 1. Okay, so along with the previous water contained in the previous cardboard, we are adding 1 unit of water more. So the answer will be 3 plus 1 will be 4 here. Okay, now after that we are adding another cardboard of size 4. Now when we are adding some cardboard which is greater than the height of all the previous cardboards, then we have to take the entire thing and fill the water in this section. We have to fill the water in the entire section. So the total water is nothing but, we have 3 cardboards, so there will be 3 into the height of this cardboard, 3 into 4. Okay, 3 into 4. So the answer here will be 12, right? Now after that we will get another 1. Okay, so when we are getting some 1 which is lesser than the previous cardboard, we will be adding this amount of water, 1 unit of water. So the answer here will be 13. Now 3, 1, 5, 1, 4. Okay, so 4, after 4 we will try to find what is the previous maximum, previous one which is greater than this, right? previous one greater than this will be this one. So we are trying to fill this position. So the total number of cardboards here are 2, right? And height of this cardboard is 4. So 2 into 4, uh, this will be 2 into 4. Okay, 2 into 4 will be 8. 8 plus this 12 will be 20. Okay, 8 plus 12 will be 20. I think I am missing something here, right? Let me jump here. 3 1 3 1 4 1. Okay, 3 I think I have missed this. This will be of height 5, right? This is not height 4, this will be of height 5. So that is the thing I missed here. This is of height 5. Okay, so after adding this with 5, height 5, this is greater than all the previous cardboard. So the total thing stored here will be 5 into 5 25. So here the answer is 25. Okay, now let's say we are adding some cardboard of size instead of 5. Let's say we are adding some cardboard of size 3 here. Okay, the cardboard of size 3 here, then the total water content in this section will be 3 into 2 6, and the total water content in this section will be 12. So the answer will be 18 in that case. Okay, so for every section we have already determined the answer, right? We have already determined the answer here will be 12, here it is 13, and here it is 25. So after, answer is nothing but the previous one plus 1. So here the answer is 4, here the answer is 5, here the answer is 13, here the answer is 14, and here the answer is 26. So we, after we build the array, the answer is nothing but previous of the array plus 1. Okay, I think you have got it. Now let's jump onto the code. Okay, so we have to find the index of the uh, closest to this. For let's say index I, you have to find the uh, the closest to this which is greater than the height of this in the left. Okay, that's why we can use some monotonic stack. So in the monotonic stack we will be putting the indexes. Okay, so for let's say we have 3 1 4 1 5, right? 3 1 4 1 5. So let's say we are adding in the stack we will be adding index. So let's say zero based indexing here is used, so we'll be adding 0 here. Now we'll try to add 1 to this stack, but it is not possible because the height of the last element in the stack is greater than this. So this is not possible. But when we are at 4, the last element height is less than the height of the current element. So we'll pop this element from the stack and we'll put the index of 4 here too. Now for 1 it is also not possible because the last element of the stack has height greater than this index. But for the for the last element, we will pop the element from the stack and we will add the index 4 here, like that. By this way, using monotonic stack, we can find the closest greater element in the left side for the current element. Okay, so that is our stop element of the stack. Now if I is 0, we are doing st dot append I and answer dot append I. This part is not needed. You can skip that part also because this will be handled here. So you can skip that part, but as I am doing some kind of step by step approach for writing the code, that's why I have added this here, but it is not needed. Now this part is for popping all the elements which is less than this element in the stack. So after this popping operation, the stack will be either empty or the stack will have some element which is greater than the current element. So if the stack, this condition is also not required. If the stack is not empty, then we are doing prefix will be this one. So if the stack is not empty, then we will try to find this one, 12. We'll get this value 12 plus I minus this index. So the value will be 2 into uh, h into h of I. Okay, let's say this one, let's say this one is of height 3, let's say this one is of height 3, then our value will be 3 into 2 plus 12. I have already explained. So the answer will be 18 here. Now if the stack is empty, then this is nothing but hi into I plus 1. We are taking the entire thing on the left side. Okay, and we are doing answer dot append c plus 1, and we are doing prefix of I equals to c and pushing the current element in the stack, and at the end we are printing the answer. This is order of n solution, and this is a good problem of monotonic stack. You can if you want to solve something similar to this, I will suggest trapping rainwater problem in LeetCode. that is quite similar to this problem. Also container with most water, that is also similar to this type of problem. Okay, you can check that out too. If you find this video helpful, please like the video and subscribe to my channel. And if you have any doubt in any part of the explanation or video, you can always ask in the comment section. I will try to reply each and every comment. Thank you.